Dr. Sanchez, this is problem set 10, number 10. It's our last video. Hope you enjoy. Alright, so are there any three-digit numbers A such that A has digits A, B, and C, where A factorial plus B factorial plus C factorial equal A, the original number? So basically, the digits of the number A, so A could be some number, let's just say it's 254. So 2 factorial plus 5 factorial plus 4 factorial should equal 254. That's what this problem is trying to say. Are there any possibilities where that's true? In this case, I'm pretty sure it's not. But like, alright. So, are there any three-digit numbers? That's a key right there. So what I found out right now is that like no digit can be 7, can be greater than 7 or equal to 7. Because 7 factorial is not a three-digit number. It equals something like, it's like 720 times 6, so it's like, it's not a three-digit number.
Times 7.
What?
720 times 7.
Yeah, and that's like, 140 something like that. Anyway, not a three-digit number. So that eliminates so that eliminates every digit being 7. But we also found out that no digit can be 6, because 6 factorial is 720. So when you add anything else to that, because you're just adding the digits together, adding the factorial of the digits together. So that would make the first digit greater than or equal to 7, and since no digit can be 7, we eliminated no digit can be 6. Then we found we could limit our possibilities even further. So once we have these two steps, the greatest possible three-digit number we can have has to be 555. But 5 factorial plus 5 factorial plus 5 factorial equals 360. So that made a major hole in our theory. The first digit must only be 1, 2, or 3. because that's the greatest oh my god, I'm sorry about that. Yeah. Since 5 factorial plus 5 factorial plus 5 factorial equals 360, it has to be the same as the number, but it can't be because the number is just too big and the factorials just don't add up to it. Alright, Josh, do you want to take over now?
Okay.
Alright.
So, what we found out is because of this rule, we knew that it had to be 1 through 3, so we tried, the greatest number would be 355. But if you took the factorials of that was 6 plus 120 plus 120, which equaled 246, which meant the 100th digit had to be either 1 or 2. So then we first tried 255, which that got 2 plus 120 plus 120, which reduced to 242. So that meant for now our possibilities were even narrowed down, but we couldn't narrow them down even more. But what we eventually found out is that, and so we're coming down to, the first digit has to be 1 or 2, second or third digit has to be 1 through 5.
0 through 5.
0 through 5, and then the last digit, say, be 5. We eventually found out by testing a couple of numbers that the tens digit could never be 5 because 1 factorial is 1, 2 factorial is 2, so with the 24 plus 120 is 144, so, and then 120 plus 120 is 240, and then 120, say, plus 2 plus 6 is, that would be 128. So we found out that the 10th digit had to be either 1 or 2.
2 or 4.
Yeah, 2 or 4,
yeah.
Which meant that there were 2 possibilities, which meant that it was 2 times 2 times 1, so we narrowed it down to 4 possible options.
Yeah. Just to add in just a comment, you want to just film me again? Yeah.
Okay.
Yeah, so what we did here is we added numbers together. we we have to have 1 or 2 being in the hundreds digits. So it's one of these numbers plus any of these plus 5. So I mean, any possible combination of these, like, you know, you're only adding 3 or 4 one time, because like that's the only place where you can have a 3 or 4. Like it's the tens digit or the ones digit, we don't know. Yeah, but there always has to be a 5 in here. So because you're adding a 5, a 1 or a 2, and anything else, the tens digit always has to come out to be either 2 or 4, because, you know, 5 plus 4 plus 2, the tens digit's going to be 4. Or, you know, 1 plus 2 plus 5, tens digit's going to be 2. And any combination of these, tens digit's always going to be 2 or 4. So that limits our possibilities to this. You know, it has to be 1 to 2, 1 or 2, 2 or 4, and the last digit has to be 5. And that gets you to our last 4 possibilities right here. And, you know, hey Josh, let's talk.
Okay, so we tried it. It could have been either 125, 145, 225, or 245. So I tested 125. That got me 1 plus 2 plus 120, which equaled 123. So I knew that one didn't work. 145 would be 1 plus 24 plus 120, which equaled 145. That worked. 225 got 2 plus 2 plus 120, which equaled 124. So that didn't work. 245. I tried to 2 plus, it would be 2 plus 24 plus 120, which equaled 146. So that didn't work. So 145 was the only one that was an option.
Yeah. 145 was the only 3-digit number that, you know, that fit the pattern or rule or whatever that you put out. All right, so any final words, Josh?
I'd say that, so in conclusion, we found that 145 was the only option, and we showed you through the logic. Have a nice day.
All right, have a nice day.